In this video, I'll demonstrate how to program the finished toolpaths for the pocket in the bottom of my part. For this pocket, I left 2.5 millimeters on all walls and 0.5 millimeter on the floor for the finished tool. The 2.5 millimeters on the wall is double what I would typically leave for a finished tool. If this was being cut on a horizontal mill, I would have left 1 millimeter or less, since the chips are easily flushed out of the pocket with the coolant. However, this part is being programmed for a vertical mill, and I'm worried the coolant will not flush all the chips out of the pocket during the roughing, and this can cause a bad surface finish if the chips are recut. If I hear the chips being recut, I can use the M01 to stop the machining, open the door, and clean the chips out of the pocket before the finish cut. Or code an M00 at the end of the last roughing tool so the machine will always stop and the pocket can be cleaned of chips each time before the finish passes. To finish the pocket, I'll use a 3/16 high-speed steel 4-flute end mill. This tool is approximately 10 thou smaller than the maximum tool diameter of 5 millimeters. And this size difference when cutting aluminum should be enough not to introduce chatter in the corners. Due to the fact that the bottom has 0.5 millimeter of material to be removed, I'll feed the tool to depth over the center hole. Then I'll spiral the tool out until the tool is near the material left on the wall, at which point I'll code 2 semi-finished passes of 1 millimeter each and a final pass removing the last 0.5 millimeter from the walls and the floor. To have the tool move in a spiral pattern, I'll code a series of progressively larger half circles. And to clean up as much of the bottom as possible, I'll continue the spiral out until the tool is within 0.5 millimeter of the finished pocket wall. Each arc will increase by 1/4 of the tool diameter. The last arc of the spiral will sweep through 90 degrees and end with the edge of the tool 0.5 millimeters from the finished pocket wall. Then I'll code a full circle. Before I program the final 3 passes, I'll first code the rectangular shape, because if I do not, there will be 4 small areas of the bottom not cleaned up, as shown by the red surface. Now I'll code the 3 finished passes, and the pocket will be completed. To code the next pass, I'll offset the final pocket geometry by 1.5 millimeters, and program these X and Y coordinates using cutter compensation. To code the second final pass, I'll offset the pocket geometry by 0.5 mil, and program these X and Y coordinates again using cutter compensation. Lastly, to take the final pass, I'll again use cutter compensation and program the pocket geometry. The arcing on and off of each pass should not leave any witness marks on the pocket wall. In the next video, I'll demonstrate how to program a pocket with an island.